Initializing.
Hello! In the previous lesson, we discussed the training board and mentioned how we need to tell the microcontroller which I/O pins to use when we want to control the components and devices connected to those pins. In this lesson, we will look at I/O pins and signals. Let us first understand what a signal is before moving forward. In microcontrollers, a signal is volts, anything from 0 volts to 3.3 volts. A microcontroller like the ESP32 can be programmed on how each pin should behave. On the one hand, a microcontroller can place a voltage on a pin, or it can read a voltage on a pin. The pins on a microcontroller can be set as an input or output. So what is an input? Inputs receive a signal, volts, from external components such as sensors. The microcontroller processes these inputs to make decisions or take actions. For example, sensors like temperature sensors or light-dependent resistors, LDRs, provide continuous data about environmental conditions. The ESP32S3 reads these signals to determine what action to take next. Output. Output pins send signals to components. These signals, as we just talked about, are a voltage from 0 volts to 3.3 volts. For instance, when the ESP32S3 sends a high signal to a buzzer, it produces sound. So, a signal can be an input or an output, and you can program each microcontroller pin on how it should behave. We also say that the mode of a pin can be programmed to be either an input or an output. A pin cannot be both an input and an output, but a signal can also fall into two types of signals, called analog or digital. What are digital signals? Digital signals operate in a simple on or off fashion, just like a regular light switch. They are either high, on, 3.3 volts, or low, off, 0 volts. You'll use these digital signals to make your projects react to the world. Let's meet the players. Push button. It's like a doorbell. Press it, and your board gets a digital on. Indicator LEDs. Small lights controlled by the board, used to signal status, warnings, or progress. Next, let us look at analog sensors. What makes analog different? Unlike digital signals, which are simply on or off, analog signals can have a range of values, like a dimmer switch or a speedometer. Analog means smooth, continuous change. Meet the analog sensors. LDR, light-dependent resistor, I/O4. This sensor detects how bright or dark it is in the room. The board reads its value, not just high or low, but anywhere from 0, very dark, up to around 4095, very bright. Potentiometer, I/O5. It's a dial you can turn. Rotating it changes the resistance, and the board gets values from low to high. It's often used to adjust sensitivity, volume, or thresholds. That's a wrap. Just a reminder, most lessons include written lessons or PDFs. This documentation provides details for each video. They are essential to study.
Initializing.